So we can, once we kind of figure out which molecules are going to bond together, we can also predict the shape of their molecule using the VSEPR theory, which is the valence shell electron pair repulsion theory. So this is basically the idea that like charges will repel each other, as we talked about with ionic bonding. So your electron domains try to be as far away from each other as possible. There's two things that essentially dictate that: the number of electron domains that you have, and also the number of lone pairs that you have, because lone pairs want to be further away from each other than bonded pairs. So that's important as well. So really, there's four main shapes with the VSEPR theory that you need to know. Your bent or your V shape, where you have one molecule in the middle, two other molecules joined to it, and you may or may not have two lone pairs on the other side. You have a linear molecule. This could be linear with one bond, two bonds, or three bonds. Trigonal planar, which is where you have a middle molecule bonded to three things and potentially one lone pair. And then tetrahedral, where one molecule is bonded to four other things. So it's really bonded to one, two, three, or four other things, plus or minus some lone pairs. So how do we determine the shape, the VSEPR shape of something? Well, the first step is to draw an electron dot diagram to figure out how many bonded pairs you have, as well as how many lone pairs you have. Then you can count your number of domains, so number of both lone pairs and bonded pairs, and determine the arrangement that will result in the maximum distance between the charges. It's important to note that your double and triple bonds are considered one domain, so you wouldn't consider them as two or three domains, so it's just one, like you would a single bond. So you can have a go at these ones: NH3, CH2O, and HNO. So have a go at those, and you can put your answers in the chat, and I'll reply in the live chat if you guys have gotten the correct answer or not. So have a go at that while we're going through some of the rest of it. So this gives you a good overview of your molecular shape as it relates to your number of electron domains and also the number of lone pairs. So this is a really useful diagram. So if you have two electron domains, so basically you have the potential to form two bonds sort of thing, it's going to be a linear molecular shape, whether you have a lone pair or not. If you have three electrical domains, if you have a trigonal, you'll have a trigonal planar if you have no lone pairs, which makes sense because you're going to have 1, 2, 3. They're all as far away from each other as possible. If you do have one lone pair, then one of your lone pairs will go up here, and then these two are as far from each other as they can be, being further away from the lone pair. Because remember, lone pairs kind of push the other things away more than a bonded pair does. Great. Then you have your 4 electron domains, which is the maximum. And so this just depends on how many lone pairs you have. If you have no lone pairs, you have 4 different bonds. That's tetrahedral. 1 lone pair, that would come out of here. 2 lone pairs, here and here. 3 lone pairs, 1, 2, 3. So it just depends on the number of lone pairs you have. So that's why your electron dot diagram is super useful, because it will allow you to figure out how many lone pairs you have.